All right, when we graph this first example, they're both in slope-intercept form, so it was easy to start the graph. But we saw we could not see exactly where they crossed. We had to use technology to find that answer. So on Desmos, we could see that they cross at the value 1.8. The solution would be 1.8, comma 0.4. Okay, again, we couldn't see that on a graph, so we learned now we're going to have to use another method to solve for the solution. Here's somebody's work for part D, where they saw they had parallel lines. Let me zoom in a little bit better here. So they actually solved these for both y, which is the best way to graph these, get the y by itself. And they noticed that these lines don't cross, they're parallel, but also we can see that before we even graph it. We can see that they have the same slope of -3, but a different y-intercept. Remember back when we were doing graphing and parallel and perpendicular lines, we saw if we had the same slope and different y-intercepts, those lines are parallel and they will never cross, which means they have no solution. All right, so we saw we could not see the exact answer on the graph in the previous example in our warm-up. So we have to find another method to solve, and that's going to be algebraically. So we're looking at the very first method of algebraic methods. That's substitution. Okay, this is one of two ways. So when you're reading a problem in the homework or on a test and it says solve the system algebraically, you're going to have to use one of these two methods. Today is substitution. In a couple days, we're going to learn elimination. All right, I'm going to go through the first example as we write the steps here. The first step, if needed, again, this is a if needed over here, is to isolate one of the variables, if needed. And I want to put an emphasis on one. You only have to get one variable by itself with no coefficients other than one. So emphasize the one here. So we can see down here, this example, we already have two variables isolated. This y is by itself on one side, and the other y is also by itself on one side. So those are two isolated variables. The next step, if we don't have step one, is to substitute. So we're going to substitute the expression from the isolated variable into the other equation and then solve. So we have the expression for the first one here, 2x minus 3. We're going to take this 2x minus 3 and we're going to substitute it in for y in the other equation. So that would look like this. That y gets replaced, so now it becomes 2x minus 3 equals 4x plus 5. That's our substitution there. You could do the other way. You could take the 4x plus 5 and substitute in for the other y. It's the same equation, just the other way. All right, there's our substitution, and now we're going to solve for x. So I'm going to go ahead and subtract 2x from both sides. What's the next step here to get solving for x? Subtract 5 from both sides. That will give us what over there? Negative 8 equals 2x. Our last step to solve for x here. Divide by 2 on both sides. Divide by 2 on both sides. That's going to be x equals what? Negative 4. Is that my answer then? No, that's just the half of it. It's the x half of the answer. So down here for my solution, we already have half the coordinates. We know the x value is negative 4. How am I going to figure out my y value? Plug in negative 4. That's the next step. So we're going to substitute on our next step the answer that we just got, not an expression this time, but the answer, that'll be negative 4 down there, into, well, first of all, that came from step 2. And we're going to put it into the equation from step 1. Whatever is the isolated equation is. And then we're going to solve. So we're going to take this negative 4 And we could put it in for either of these x's up here. You could put it in the first one or the second one. Just choose one. Second one sounds good.
Oh, I did the first one.
You'll get the same answer, either one. All right, so y equals the 4 times our answer, -4 we got, and we are adding 5. What's -4 times 4? Plus 5? -11. Y is -11.
Hold on. I did that wrong.
Again, if you plug it into the other equation, you'll get the same answer. 2 times -4 is -8. -8 minus 3, -11.
Oh, okay, now I know I did.
All right, so how many solutions do we have then? One. And what does that represent? Where the two lines cross. Don't forget, we are talking about lines crossing still. Where the two lines intersect. All right, let's move to the next example down below. But before we do that, the last thing you can do to make sure your solution's right, we kind of talked about it verbally, is you can test your solution. That means plug your x into both of those equations to see if you get a true statement. All right, so put it into both of those linear equations. And we kind of did that. We talked about if I put -4 into the other equation, I still get -11. That's a way of checking. All right, let's go to the next example down here. Now, look here. We have 4 variable terms, 2x, 2y, 1x, and -4. I want you to identify the one that's going to be the easiest to get by itself. Which one? The bottom x. The bottom x. Now, why is that true? Why? Oh, say that again. You won't get a fraction. When we take this x and get it by itself, we won't have to divide by a number. If I want to solve for this y, eventually I have to divide by -4, which makes fractions. Over up here, eventually I'll have to divide by 2 on either one and get a fraction like 3/2. You don't want to do substitution with fractions. So instead, choose the one that has a coefficient of 1. That's your target always. So we're going to get that x by itself by doing what first? Adding 4y to both sides. We're going to isolate that x to get it by itself by adding 4y to both sides. Okay? You don't have to get the y by itself. Whatever's easiest. Okay? That one was the easiest, was x. Now we have an expression, 4y minus 1, and we're going to go up and replace, substitute in that expression for x above right there. So this is step 2, substitution, where we take that top equation and we're substituting in what we solved for in the bottom one, 4y minus 1. Everything else is still there, 2y and equals 3. All right, now we're going to solve for y up there. Notice we went from a variables of 2x and 2y to just a y equation up here, y variable. So we're going to solve. Our first thing to do is what? Distribute. We're going to simplify and then solve here. So 8y minus 2, still got plus 2y equals 3. Our next thing to do is to combine like terms. Good luck if you're not paying attention. So that'd be 10y minus 2 equals 3. Okay, we're not done yet. Solving for y. What's my next step? Add 2 to both sides. Very good. 10y equals 5. Last step. Remember, always double check it on the calculator. 5 divided by 10 is going to give us the y value of 1/2. 5 over 10 reduces to 1/2. So is that my answer?
No.
That's just the half of it. That's the y half. I'm going to use that joke over and over again. That's just the half of it. It's actually literally a half too. Now, we have the y value. Now, how do we get the x? Yeah. Plug it in up there. Which one? You want to plug it into the first equation, the second one, or the x one? Not the first nor the second, but the x one right here. You already have this equation in another form. They're equivalent to each other. So all we have to do is replace y, and we will get the answer for x. So we're going to take that 1/2 and substitute it in, for y. So that would be our step 3. X equals 4 times 1/2 minus 1. So 4 times 1/2 is 2 minus 1 is 1. So the x value is 1 for that solution. So that, remember, that's where the line crosses, and that means it crosses how many times? Once. One solution for one point of intersection. Padawan practice for this first example back here. Go ahead and try this on your own first. If you're getting stuck in the first step, you have 2 targets to choose from. Get this y by itself, or get the other y by itself. Those are the positive 1 coefficients to get by themselves. All right, for the this example, I'm going to go ahead and get the first y by itself. Okay, so I'm going to undo that one there. Either one's fine, though. I'm going to do that first one, though. So negative x plus y equals 1. So I'm going to do what to get that y by itself? Add x. One step away to having a variable by itself. Y equals x plus 1. Next, I'm going to take this and substitute it into the other equation. So if I got it from the top one, it's going to go into the bottom one, wherever the y is, right there. That y gets replaced. So I'll have 2x, whoops, wrong pin. 2x plus my substitution of x plus 1 equals negative 2. All right, now we're going to simplify to solve for x. We have a positive 1 on the outside here, so nothing changes. So I do have like terms of 2x and 1x to make 3x. Still got plus 1 over there equals negative 2. Next step, subtract 1. 3x equals negative 3. My last step is to divide by 3 to get x equals negative 1. My last step for solving for x, because that's only half the answer. Negative 1 will be our x value. Now we got to figure out the y value. Good thing we have a y equals equation up here. All we're going to do now is substitute our answer in for x in the other equation. Y will be negative 1 plus 1. What's that equal? 0. Negative 1, 0 is our solution. The line crosses once for one solution. All right, the last example down here is going to be one of our special kind of answers. What's cool, though, we already have a variable by itself. Do you see it? I hope you do. That y is by itself. That means I could jump into my substitution. I could take this 3x minus 1 and substitute it in for the y down there. So negative 6x plus 2 times my substitution, 3x minus 1, equals negative 2. There's my first substitution. And then we substitute the y. It's gone. Okay. Now I'm going to simplify to solve and see what happens. Negative 6x and then positive 6x minus 2 equals negative 2. Combine like terms and what happens? They cancel out. We get 0x. They go away and we're left with a mathematical statement. Negative 2 equals negative 2. Is that true or false? True. And if you remember from solving regular linear equations, we got a true statement that showed us what? How many solutions? Infinite solutions. Infinite solutions.
Oh, that's why you told me that. Okay, now I get it.
So your solution is infinite solutions or many solutions. And it's the same answer for many solutions down there. Okay. All right, don't forget, when we have this come out in our algebraic solution, infinite solutions, a true statements, don't forget that means these lines are doing what? They are coinciding. Don't forget that term means they're existing in the same space. They're the same line. And maybe some of you actually noticed that if you were to solve this equation, the second one, for y, you would actually end up with the exact same thing, 3x minus 1. All right, may the math be with you.